everyone, welcome to On Tuition. We are meeting after a very long time. For last few days, I was busy in making a very interesting and amazing tool of learning. It is called the magic board. So in between you and me, there is a special type of glass and a special type of technology based on total internal reflection. Also a special type of total internal reflection that is called frustrated total internal reflection. So I was working on this and I kept on trying and finally I could make this arrangement. So let's start today's session with this magic board in front of you. Today we are going to discuss a very simple and common thing in physics that comes under laws of motion, which is called Atwood's machine. So it is nothing but a pulley and mass system like this. Suppose a pulley is hanging from ceiling, and with this pulley, two masses are hanging like this. The masses are say M1 and M2. I'm sure that you have found this type of problems in several places, but we solve this type of problem in general way which takes much time. Suppose we have to find the acceleration of these masses or tension in this pulley, or tension in this upper string. So we do a normal calculation, we do the free body diagram of these bodies and we find all these things. But today I am going to tell you a special trick with which you can solve this type of problems within seconds. To understand this trick, let us first try to calculate this acceleration and tension in this common problem. So let us assume this acceleration is upward A, and similarly this acceleration will also be downward A. So I can draw the free body diagram of the masses separately. So M1 there is a tension T upward and there will be a weight downward M1G, and the acceleration is upward A. Similarly for N2, I can draw the free body diagram like this: upward tension, this downward weight M2G, and the acceleration is also downward. So if I try to write down the laws of motion equation with these two free body diagrams, I can simply write T minus M1G is equal to M1A for the first free body, and for the second one I can write M2G minus T is equal to M2A, and these are very easy to solve. And after solving, what you will find, I am writing here, the result is A is equal to M2 minus M1 into G divided by M1 plus M2. This will be the acceleration, and regarding the tension in the string, I can write the value of T you will find is twice M1 M2 into G divided by M1 plus M2. So if I have to calculate what is the tension on this upper string which is connected between the ceiling and this pulley, definitely the tension will be 2T, and the tension T prime, suppose this tension T prime equal to 2T, that will be 4 M1 M2 into G divided by M1 plus M2. So why I have calculated all these things? To represent this entire diagram by a single mass like this. If I represent this entire diagram by a single mass, which I say it is M equivalent, can I say that the M equivalent will be in such a way that it will also produce the same tension 2T between the string connected between M equivalent and the ceiling. So this 2T and this 2T will be the same, and this 2T will be equal to M equivalent into G. So if I compare these two equations, then you will get to know that the mass equivalent of this system can be written as 4 times M1 M2 divided by M1 plus M2. So I can replace this entire system by a single mass like this. And it always happens even if this pulley and mass system is accelerated. For example, if I, instead of assuming that the ceiling, it is connected with a fixed ceiling, if I assume that it is connected with an elevator which goes up or down with some acceleration in time, then also I can substitute this entire thing by this mass equivalent without changing anything. Why? Because instead of writing this G in this entire calculation, what I will write will be G equivalent, which will be G plus A prime if it is going upward, or G minus A prime if it is coming downward. But in all these cases, this 2T will also be equal to M equivalent into G effective. So in that case, G effective will get cancelled out from both sides, and I will get this mass equivalent value the same. So now how this mass equivalent concept is going to help me, that we will try to understand by taking one or two examples. So let us take this example where a block is placed on a smooth tabletop and it is connected with a fixed pulley and a string. The other end of the string is connected with this Atwood's machine, which is hanging like this. So there is no friction, mu is 0. Let us assume the mass to be m to m like this. Anything you can assume. Now if I have to find what is the acceleration of this block that is kept over the tabletop, how we can do that? We can simplify this person in this way. We can say that the same diagram can be redrawn with this one, where this is m and what is this one? We can say it is mass equivalent. In the previous problem, we have seen that the mass equivalent can be written as, the formula was 4m1 m2 divided by m1 plus m2. So in this case, I can say it is 8m by 3. So now very easily and quickly I can find the acceleration of this block, which will be 8mg by 3 divided by m plus 8m by 3. So it will be 8g divided by 11. That will be your answer. So if we do not use this mass equivalent concept, even in that case, we will be able to solve this person by drawing free body diagram of this one and this block separately and writing their laws of motion equations, and we will solve those equations and we will finally find the value of acceleration, and you will find the same value of acceleration. So what does this concept actually do? This concept is saving our time. So let us take one more example of that. Now look at this problem where there is not a single pulley or double pulley system, but instead we are having an infinite pulley and mass system, and mass of each of these blocks are given to be m. Now if I ask you what is acceleration of this first block, let us assume this to be a. Can I solve it by this mass equivalent concept? So in that case, what I have to do, I have to find the mass equivalent of this entire portion lying on one side of this pulley. Let us assume the mass equivalent of this portion to be x. Now as you can see that this is an infinite system of mass and pulley. So if I subtract one system from an infinite system, the system will no longer change. So in that case, can I say that the equivalent mass of this lower part is also x? Because this part is 1 minus of this part, which is an infinite system. So if this has an equivalent mass x, it must have equivalent system x. So how do I find the value of x? Now can I say this value x can be written as 4 into m into x divided by m plus x. If I solve it, you will find the value of x to be 3m. Now this complicated system is transformed into a very simple system of mass and pulley. This mass is m and another mass is 3m. And if I ask you what is acceleration of this block, you can readily say that it is 3mg minus mg divided by 4m, which is going to be g by 2. That will be your answer. Not only in this problem, you will be able to solve several type of problems uh, which consist of this type of Atwood's machine by simply using this mass equivalent concept. We can also modify this system a bit and we can find the answer. If I ask you what is the acceleration of this block, if the masses are in GP, that means m, the next mass is 2m, this next mass is 4m, this will be 8m, like this. How you will solve it? You can try it for a second by pausing this video. I'm sure you will find a solution. Now in this case, if I assume that this entire system has mass equivalent x, what will be mass equivalent of this system marked inside a red dot? Now you have to understand that this will no longer be x, but it will be a 2x. Now you have to see that if I multiply all these masses by a factor 2 inside this white box, I will find a system inside this red box. So only change will be here, that x equal to 4 into 2m into 2x divided by 2m plus 2x. So when we solve it, you will find the value of x to be 7m. So acceleration will come 7mg minus mg divided by 8m. The answer will be 6mg by 8m. So 3g by 4. That will be your answer. So remember, from this time, whenever you will find an Atwood's machine system connected with any type of other system, don't forget this formula, m equivalent equal to 4 m1 m2 divided by m1 plus m2. Thank you for watching.